Hello, this is Ms. DB, and in this video we're going to go over how to do a few of the problems from the Chapter 10, Section 3 worksheet on formulas in 3 dimensions. You will definitely want to take some notes. These are some new formulas that you haven't used before, and you need to make sure that you do them correctly. We'll also be using our calculators for this lesson. The last couple we just looked at different ways of viewing three-dimensional figures. Now we're going to actually calculate some different things about those figures. So first we're going to talk about the definition of polyhedron is a solid formed by 4 or more polygons that intersect only at their edges. Prisms and pyramids are polyhedrons. Cylinders and cones are not, because cylinders and cones have parts that are not polygons. A sphere is not a polyhedron. So every face has to be a polygon. If you have a polyhedron, you can use Euler's formula. It looks like Euler, but it's pronounced Eulers. And Euler was a mathematician who figured out lots of different things, and this is one of his simple and elegant formulas that he found out about polyhedrons. He noticed that for any polyhedron with V vertices, E edges, and F faces, this would be true. If you take the number of vertices and subtract the number of edges and then add the number of faces, you will get 2. Now you might see this written slightly differently. Sometimes, it'll be -2, or the equals and the equals E. So let me get my pen here. If we had added E to both sides and subtracted 2. Actually, sometimes you'll see it written that way, that V plus F equals 2 plus E. Sometimes you'll see it written this way. Sometimes you'll see V plus F minus 2 equals E. So there's different ways of writing it because it's algebra, and you can rearrange by adding or subtracting the same thing from both sides. But our book uses V minus E plus F equals 2, and that's fine. This is the way I learned it in school. In any case, once you have figured out how many vertices, how many edges, and how many faces, then you can plug them back into the formula and verify that it works. That's what it means when it says use your results to verify Euler's formula. Now, the number of vertices, edges, and faces, that's something that we talked about in 10.1 when we did our first section. So go back and review that if you don't know what a vertice, edge, or face is. So for which one should we do here? Let's do number 3. We're going to write the vertices, how many vertices they are, how many edges there are, how many faces there are, and then we will verify the formula, Euler's formula, and you can use any of the forms that you like if you want this one or perhaps this one. Okay, let's count the vertices for number 3. The vertices are where the faces meet at a point. So there's 1, 2, 3, 4, 5, and then there's one more down at the bottom. So there is 6 vertices. Let's count the number of edges. The edges are that line segment where 2 faces meet. So there's 1, 2, 3, and there's one in the back. That's 4. Let's do the bottom pyramid too. That's 4, 5, 6, 7, and there's one that's hidden, 8. And then there's where the 2 pyramids are meeting. So there's 9, 10, 11, 12. I got 12 edges when I counted. All right, now faces. The faces they're all triangles here. We have 1, 2, then there's one in the back, 3, 4. There's 4 for the top pyramid, and there's 4 for the bottom. 5, 6, 7, 8. So I got 8. Now we're going to use Euler's formula and verify that we get 2. If we don't get 2 when we take V minus E plus F, then recount and see where your mistake is. Because if it doesn't equal 2, then you made a mistake. So I'm going to take V minus E plus F equals 2. I want to see if it equals 2. It's like checking. So V is 6, E is 12, F is 8, and I want to see, does that equal 2? 6 minus 12 is negative 6 plus 8. Negative 6 plus 8 is 2. 2 equals 2. It checks. It works. So that is how you do these problems. You find the number of vertices, the number of edges, the number of faces, write it down, and then plug them into the formula and make sure that you get the same number on each side. In this case, 2 equals 2. All right, the next thing that we're going to learn about is the diagonal of a right rectangular prism. So if you go get a shoebox and tie a string to this top front right corner, left corner, and then tie the string also to the bottom right corner, then you will have the diagonal of a right rectangular prism. Oh, and the back too. So it'd be in the right, it'd be in the back, and it would be at the bottom. And the way that we calculate the length of this diagonal, it looks very similar to the Pythagorean theorem, but with an extra piece. Because Pythagorean theorem is for two-dimensional figures, we have three-dimensional figures. So this is an L for length. It's a cursive L. So this says that we will take the distance from that point to that point of that diagonal is equal to the square root of L squared, the length squared, plus W squared, that stands for width, plus H squared, that's the height of the box. And here it tells you what each of those variables stands for. Here's an example problem, and again, that's a cursive L. And let's do a problem here. Now, if they're asking us for the length of the diagonal, we'll use this formula exactly as it is. So you would just write D equals the square root of L squared plus H squared plus H squared, and then you'll plug in length, width, and height into that formula. And that's the same for number 8. Number 5 and number 8 are asking us for the length of a diagonal. So for both of those, you'll just use the formula exactly as it is, and you'll be solving for D. But in 6 and 7, they give us the diagonal. So we'll be plugging that in right here in the formula. And then they also tell us some other parts. So we'll be looking for a missing part that's underneath the square root. So it's a little different. So in number 6, I have to get a little more room here. In number 6, we're looking for the height of a rectangular prism, and then they give us the length and the width of the base. So I'll call this the length, and I'll call this the base, and they also give us the diagonal length. So what we're looking for is the height in this picture in number 6. But we're still going to use the same formula. It's just that the things that we'll plug in will be in different places. So L squared plus W squared plus H squared. Let's go ahead and put into the formula the parts that we know. The diagonal is 9. The length is 4. And I'm going to square that. The W is 5, that's given in the problem, so I'll put 5 in, and don't forget to square that. And I'm looking for H. I'll color that in blue. So, and that's squared too. All right, so if we're looking for H, and right now there's all of this stuff going on, there's things being squared, and it's to the square root of, let's begin by getting rid of the square root. What is the opposite of taking the square root of both sides, or taking the square root? It is squaring. So I am going to square both sides of my equation, because that undoes the square root. So now I have a simpler problem of 9 squared equals, I undid the square root, so now I'm just left with 4 squared plus 5 squared plus H squared. This is a much simpler form. Now I could go back up here to my original, and I could do that to this equation and get an equivalent form of how to find the diagonal of a right rectangular prism. D squared will be equal to L squared plus W squared plus H squared. If you add this to your notes, you can use either form of this formula now. So now you have two congruent equivalent ways of finding the diagonal. It's just that in the one that I just wrote, it's D squared. So if you were looking for D, then you would have to take the square root of both sides. But if you're looking for L or W or H, then this one is an easier one to work with. All right, so now I've got just a simpler problem to do. You square everything. 81 would equal 16 plus 25 plus H squared. I don't know what H squared is yet. And then you can add the 16 and 25 together. So 81 would equal, let's see, that's 41 plus H squared. And then we'll subtract 41 from both sides. And 81 minus 41 is 40. Now let's look back and see how did they want us to leave our answer. It says round to the nearest tenth if necessary. That means that you can go ahead and use your calculator to figure out what the square root of 40 is. It means you don't have to simplify the square root. You can. You could say, well, where's my calculator? You could say that the square root of 40 is equal to the square root of 4 times the square root of 10. And the square root of 4 is 2, so this would all simplify to 2 square root of 10. However, the directions said to write this as to the nearest tenth. So I'm going to go ahead and figure out what is the square root of 40. Square root of 40 is equal to, oh, I have to do it backwards on this calculator. Square root of 40 is equal to 6.32455. They said round to the nearest tenth, so the number after the 3 is a 2, so I can just leave this as 6.3. So that's approximately 6.3. And then you're done. And number 7 will be done similar to that. You'll be looking for the edge length, so you'll be looking for L, and they give you D. But wait, we don't have any other information, except that it's a cube. In a cube, all of the dimensions are the same. The length is equal to the width is equal to the height in a cube. So that means that if we use this formula, actually, let's use the formula that we adapted by squaring both sides. D squared equals L squared plus W squared plus H squared. In a cube, L and W and H are all equal to each other. So we can use L for all of them if we want, right? Let's write that. So D squared would equal L squared plus L squared plus L squared. We only need to know what L is. What is L squared plus L squared? Well, that's 2L squared. What's L squared plus L squared plus L squared? That's 3L squared. So we really have that D squared is equal to 3L squared. And then we will put in that D is 9. Switch to a different color here. So 9 squared is going to equal 3 times L squared. And then you'll continue solving to find what L is. 9 squared is 81. Now how do I undo the 3 times L squared? You divide by 3. And 81 divided by 3, I believe, is 27. So now we have 27 equals L squared. And then you would take the square root of both sides. And the square root of 27 is 5.196, which rounds to, I should have gave myself more space here too. 5.196 rounds to about 5.2. I lost my part of my work there. You can finish it up on your own paper and give yourself more space before you write these in. All right, so the next part we're going to look at is a three-dimensional coordinate system. So instead of just x and y, we also have z. Now, x and y are right here. Picture that as a piece of paper, horizontal piece of paper, and z-plane is going through that piece of paper. So the coordinates of a point in three-dimensional space have 3 coordinates, an x, a y, and a z. And they gave a point right here. Now it's, again, hard to do this when you're writing in Word, but we can, hard to picture this. But you can also find the distance, we can find the distance between 2 points in the 3D coordinate space using this formula, and we can find the midpoint. Now you can see that the distance formula is very, very similar to the distance between 2 points in a two-dimensional system with the extra part added of z sub 2 minus z sub 1 squared. And the midpoint is very similar with the additional coordinate where you would add the 2 coordinates of z and divide by 2. So in the next problems, you are going to be using the distance formula and the midpoint to find both the distance and the midpoint between 2 points. Make sure you show your work. Make sure you do this correctly. Now, we've been working with distance formula all year, so you should be good at that. You just have an extra piece to add. And midpoint formulas really aren't very challenging at all. Let's do number, and you'll see there's not very many negatives here. Only number 14 has negatives in there, so be careful when you subtract on that one. Let's do number 13. Now, I did put the formulas back on this page so you can look back in the directions. I'm going to do them by hand rather than typing. The distance formula is found by taking the square root of x sub 2 minus x sub 1. So we're going to subtract the x values and then square it. And then we're going to subtract the y values and square them. There's the y values. And then we're going to subtract the z values. Oops, I almost made a plus sign there. And then we'll square that as well. Make that a little longer. And then when we're done, we take the square root of the whole thing. And that's what the distance is going to be equal to. All right, let's plug in the numbers. We've got, here the reds are the z's. So for the x's, we're going to take the 2 x values and subtract them. So we're going to take 5 minus 1, subtract, and then square the result. For the y's, we're going to take 5 minus 10. Yes, that's negative, but when we square it, we'll get a positive number. When you square things, they're always positive. And then for the z's, we're going to take 5 minus 3 and then square that result. All right, now we will plug in or simplify. So that means we have 5 minus 1 is 4 squared. 5 minus 10 is negative 5. But remember, when we square it, we will get a positive number. And then 5 minus 3 is 2 squared. All right, keep simplifying. 4 squared is 16. Negative 5 squared is 25. Positive 25. I don't really need the parentheses. I'm going to take them away. Now, if you're doing this on your calculator and you're like, no, it keeps telling me that it's negative 25, then you're not using the parentheses. In your calculator, if you want to square this and get the right answer, you have to use parentheses. And then 2 squared is 4. So if I want to square negative 5 and see what the answer is, if I just type in negative 5 and then square it, it might not square the number. This calculator did, but your calculator might not do that. But if you put in a parentheses and then the negative 5 and then close your parentheses, see, then square it, you'll for sure get the right answer. All right, so then I am going to keep simplifying. 16 plus 4 is 20. 20 plus 25 is 45. Now it's said to round to the nearest tenth, so I can just go ahead and use my calculator and figure out what is the square root of 45, and round to the nearest tenth would be 6.7. If you want to practice simplifying your square roots, rewrite this as the square root of 9 times the square root of 5, and the square root of 9 is 3, so 3 square root of 5 is the exact answer. 6.7 is rounded to the nearest tenth. So the answer for number 13 for here is either 3 square root of 5 or 6.7. And now we have to find the midpoint. I didn't leave myself much room, but the midpoint doesn't take much room. You have to add the x coordinates together and divide by 2. You have to add the y coordinates together and divide by 2. You have to add the z coordinates together and divide by 2. Now, if you have negatives involved, be careful that you are working with them correctly, but we don't. So the x coordinates would be 1 plus 5, which is 6, divided by 2. The y coordinates would be 10 plus 5, which is 15, divided by 2. And the z coordinates is 3 plus 5, which is 8, divided by 2. And then that simplifies, and I'll let you finish that up. Divide them each by 2. All right, so that's it. The last one may take you a little while, this last section, but that's all right. Do your best and let me know if you have any questions. Have a wonderful day.